Hi, in this video I will read a part of the article Risk Management and Financial Derivatives and Overview. Risk management is crucial for optimal portfolio management, one of the fastest growing areas in empirical finance. In the expansion of financial derivatives, while some of the key uses under term risk and portfolio management are reasonably well understood. Many of the technical and empirical uses underlying the creation and movements in financial derivatives are less well understood. The purpose of the special use on risk management and financial derivatives is to highlight some areas in which novel econometric, financial econometric, and empirical finance methods have contributed significantly of the analysis of risk management, with an emphasis on financial derivatives, specifically conditional correlations and volatility spillovers between crude oil and stock index returns. Pricing exotic options using the one transformer. The rise and fall of S&P 500 variance futures. Predicting volatility using Markov switch multifractal model. Evidence from S&P 100 index and equity options. The performance of commodity trading at, at billboards. Amid variance ratio test approach. Forecasting volatility via stock return, range trading, volume and spillover effects. The case of Brazil. Estimate and simulating weighable models of risk or price durations and application to ACD models, evaluation of double trigger catastrophe options with counterparty risks. Day of the week effect on the peaks are Parisomnium's representation. Equity and CDS sector indices. Dynamic models and risk hedging the probability of default in collateralized trading operations. Risk premium in multinational enterprise solving client replication problems in a complex market with orthogonal series expansion. Downside risk management and bar-based optimal portfolios of precious metals, oil and stocks. And amplified ratios of portfolios with options application to naked futuros and listed options. It is our hope that the interesting, involved and innovative papers in the special use will encourage others to undertake research in a variety of challenging areas associated with the distinct and rapidly expanding areas of risk management and financial derivatives. Overview. In the first paper, conditional correlation and volatile speakers between crude oil and stock index returns. Xiaolin Chan and Roy Chan and Schwartz investigate the conditional correlations and volatility spillovers between the crude oil and financial markets. Based on crude oil returns and stock index returns. The returns from January to of the crude oil spot forward and futures prices from the WTI and Brent markets, and the FTSE 100, Dow Jones, and S&P 500 stock index returns are analyzed using Boller's live season model, Link and C, McLaren's Barma Gauge model, McLaren, Body and Chan's Barma Gauge model, and includes the CC model based on the CC model. The estimates of conditional correlations for returns across markets are very low, and some are not statistically significant, which means the conditional is shock and correlating on in the same market and not across markets. However, the DCC estimates of the conditional correlation are always significant. This result makes it clear that the assumption of constant conditional correlations is now super empirical. Supplying the empirical results from the Barman-Gauge and Barman-Agard models provide lead evidence of volatility spillovers between the crude oil and financial markets, giving the evidence of asymmetric effects of negative and positive shocks of equal magnitude on the conditional variance suggests that Parma-Gauge is superior to Parma-Gauge and CCC. The estimation and analysis of the volatility and conditional correlations between crude oil returns and shock index returns can provide useful information for investors, oil traders, and government agencies that are concerned with the crude oil and stock markets, especially regarding optimal hedging across the world's market. As the second paper, Conrad Laburstein and Teresa Auford analyzed the theoretical and practical use of pricing exotic options using the one train transform. The one transform allows for a simple yet intuitive approach to pricing options with underlying basis of geometric Brownian motion. The authors show how the approach can be used to price some exotic options. Examples are Jim Tom to show the convention of the one price to the Black-Scholes price for Markgraf option, a geometric-based option, and a set or nothing option. The authors also examine the range of prices that is achieved using the one transform for this option. Jialin Chan, Juan Ángel Jiménez Martín, Michel McLaren, and the odioso Pérez Amaral analyzed the rise and fall of S&P 500 variance futures in the three paper modeling, monitoring, and forecasting volatility are indispensable to sensibly portfolio risk management. The volatility of an asset of composite index can be traded by using volatility derivatives such as volatility and variance spouse options and futures. The most popular volatility index is VIX, which is a key measure of market expectations of volatility, and hence also an important barometer of investor sentiment and market volatility. Investors interpret the VIX cash index as a fear index and of VIX option and VIX futures are derivatives of the fear index. VIX is a based on S&P 500 call and put options over a wide range of strike price, and hence is not a model based. Speculators can trade on volatility risk with these derivatives with being used on whether volatility will increase or decrease in the future, while the hedgers can use volatility derivatives to avoid exposure to volatility risks. VIX and in this option and futures derivatives have been widely analyzed in recent years. An alternative volatility derivative to VIX is the S&P 500 variance futures, which is an expectation of the variance of the S&P 500 cash index. Variance futures and are futures contracts riding off on realized variance or standard set variance swaps. The S&P 500 variance futures are not model-based, so the assumptions underlying the index do not seem to have been clearly understood. As variance futures are typically traded, their returns and volatility are not easy to model accurately using a variety of volatile model specifications. The paper analyzes the volatility in S&P 500 3-month, 3-month, and 12-month variance futures before, during and after the GFC as well as for the full data period. For each of the alternative conditional volatility models and their densities in order to determine whether exposure to risk can be incorporated into a financial portfolio window taking positions on the S&P 500 index intels. In the fourth paper, entry predicting volatility using Markov swing multifractal model, evidence from S&P 100 index and equity options. When H1 tending 1 and being well being evaluate the performance of the ability of Markov chain multifractal implied gauge and historical volatilities to predict realized volatility for both the S&P 500 index and equity options. Some important findings are as follows. First, the authors find that the ability of MSM and gauge volatilities to predict realized volatility is better than that of implied and historical volatilities for both the index and equity options. Second, equity option volatility is more difficult to be forecast than index option volatility. Third, both index and equity option volatilities can be better forecast during non-global financial crisis periods than during global financial crisis periods. 4. Equity option volatility exhibits distinct patterns conditional on various equity and option characteristics and is predictably being MSM and implied volatilities depend on these characteristics. Finally, the authors find that MSM volatility outperforms implied volatility in predicting equity option volatility conditional on various equity and option characteristics. Chidonbine, Cook 5 Pond, Kian 1, and Wing Ken 1 examined the performance of commodity trend adverse, a mean variance ration test approach. In the fifth paper, the authors provide simulation evidence that the, the mean variance ratio (MVR) test is superior to the shape ratio (SR). Test B applying both tests to analyze the performance of commodity trains at differs STIC. The empirical findings show that with the CR test concludes that most of the STA funds being analyzed are indistinguishable in their performance. The Mevere statistics shows that some funds outperform others. Moreover, the shared statistics indicate that one fund significantly outperformed another, even when the difference between the two funds was insignificant or even changed direction over subperiods. Conversely, the memory statistics can detect such change when they occur in the subperiods. In addition, the authors have conducted simulations to show that the memory test possess good power, which should be very help in practical applications. In the sixth paper, entitled "Forecast Volatility by Stock Return, Range, Trading Volume and Spillover Effects", the case of Brazil for the purpose of developing alternative approach for forecast volatility. Manu Wasai and Ivan Rugal considered the heterogeneous bar model which accommodates the market effects of different horizons, namely daily, weekly and monthly effects. The authors examine the independence of stock markets in Brazil and the USA based on information of daily return, range and trading volume for purpose of comparison with the new approach. The authors also analyze the univariate and multivariate gauge models with asymmetric effects, trading volumes and fat tails, the heteroscedasticity, courage, range, causality test based on the HBR model shows strong evidence of such spillover effects. The authors assess the value at risk threshold of Brazil based on the O of sample forecast on the HBR model, and find that the new approach is satisfactory of periods that include the FSA without assuming heavy tail conditional distributions. David Allen, Kache Enega, and Sheldon Paris considered estimating and simulating Weibull models of risks on or price duration and application to asset models in the seventh paper. There is now a massive literature on both the large family of risk models and the related auto-conditional duration. Asset models used for modeling the stochastic timing of trades or price change in financial market microstructure research, but have their origins in the classic archipels B. Engel and Bollinger. The paper used the theory of estimating functional as a semi-parametric method for estimating the parameters the, of this type model. As an example, the authors consider the class of acidic models with errors from the standard Weibull distribution to Delport and estimation procedure. This method could equally be applied to gauge models. Using a large-scale simulation study, the authors show that the approach is easier to use in practice than the maximum likelihood or quasi-maximum likelihood methods. The static properties of the corresponding optimal estimates are investigated, and it shown that the estimates using both the AF and Comelle methods are comparable. However, the AF estimates are easier to evaluate than the Meyer and Comelle methods. Nevertheless, ML-based estimates are shown to be superior and perform better when the true distribution is known, but when this is not the case, the estimates are shown to be a buffer tool. En conclusión, este texto resalta como la importancia de la gestión de riesgos en la administración de carteras, especialmente en un contexto financiero donde los derivados financieros están experimentando un rápido crecimiento. Este se enfoca en cómo los métodos econométricos y las finanzas pues como empíricas han contribuido significativamente al análisis de la gestión de riesgos y particularmente en relación con los derivados financieros y pues las correlaciones condicionales. En ese artículo también se mencionan diversas áreas de estudio como la relación entre el petróleo crudo y los rendimientos de los índices bursátiles, la fijación de precios de opciones exóticas, como también el comportamiento de los futuros de varianza del S&P 500 y entre otros temas relacionados con la predicción de la volatilidad y la cobertura de riesgos. En resumen, el texto subraya la complejidad y la necesidad de utilizar herramientas avanzadas para gestionar efectivamente los riesgos, los riesgos financieros en un entorno cambiante y dinámico como este. Muchas gracias.